Hi everybody, welcome back. Today we're doing section 1.3. We're doing example 3 located on page 11 of your booklets. Today we're going to be looking at solving a problem that involves unit conversions. So we're going to read the question and then we're going to change the units when needed. So first of all, we're going to read the question. It says Alex is 6 feet 2 inches tall. To list his height on his driver's license application, Alex needs to convert this measure to centimeters. So some of you will be doing this at some point next year. So in doing so, when you go to the DMV, they look for height in centimeters, and a lot of us really only know what our height is in feet and inches. So you'll be able to convert when you do that, which is interesting. So the first one we're going to do is we're going to change this into inches first. Since it's in feet and inches, that's both imperial, what we'll do is we'll convert the feet and inches directly into inches. So what we need to do is we'll take the number of inches, and we'll take just the 6 feet part here first, and we'll change that to inches to 6 feet. A lot of you can do that in your head with mental math. That's what it says in the B part. So I'm really doing A and B here at the same time, but I'm going to show you how to do it with using unit analysis, or the factor label method, which I like to call it. Okay, so we'll open up our brackets. We're going to use our conversion factor, and we know that for every 1 foot, we're getting rid of that in the denominator. What we're going to do is we're going to put the inches in the numerator because that's where we're going. We know there's 12 inches in 1 foot. The inches will, the feet will divide out. There's your unit analysis, and that's equal to 72 inches. All right, as many of you are already aware. And then to get the total value there, all we need to do now is take the 72 inches, add the 2 inches that we were at in the beginning to equal 74 inches total. Right? Because it was 6 feet 2 inches, so we take the feet and change those inches, then we add on the inches that we already had to get a total of 74 inches. That means that 6 feet 2 inches is equivalent to 74 inches. Now what we'll do is we'll change the inches to centimeters on the next line. So we'll do unit analysis once again. And we know that x, so we put our unknown centimeters, is equal to 74 inches. We're going to multiply that by our conversion factor. Alright. And we know that for every 1 inch, that's equal to 2.54 centimeters. 2.54 centimeters. This comes from your conversion sheet that you will be given. You do not have to memorize these. You will be given these values. So we take the inches, divide the inches, leaving it with centimeters. That's why we did that. And we're going to multiply those two numbers together. And we take 74, multiply that by 2.54, and we get 187.96 centimeters. Which is approximately equal to 188 centimeters. All right. They have a different conversion in your textbook, and you're getting 185, so we can ignore that. I want to use the conversion factors that they provide you on the provincial examination, so that's why ours is a little off from the book, but that's no big deal. And to check your understanding, I know the book says 168. When you're doing this, this is going to be a little bit off. right? So when I do the quick math on that, it's actually going to be closer to 170. So I'm going to switch this on your sheet. Again, the one that's provided is a little different of how they use the conversion factor, so it's off by a little bit because it's approximation. The value that I've used up here, the 2.54 centimeters for every 1 inch, the conversion factor that I gave you, the one that we use for provincial examination, is more accurate. So that's why we'll be using the one I provided you with here today. Okay, so just be mindful of that. And we'll go to example 4, estimating and calculating using unit conversions. It says a truck driver knows that her semi-trailer is 3.5 meters high. The support beams of a bridge are 11 feet 9 inches high. Will the vehicle fit underneath the bridge? This is important because if it doesn't, then you're going to hit the bridge, obviously. So you got to be careful there. So we'll use the calculation again. This is going to be a little bit different from the one we have in the textbook. They're using different conversion factors. I want to use the ones that we are given for the provincial exam. Okay. So be mindful of that. So in this particular case, there's 2 ways you can work this out. You could change the feet and inches to meters, or you could change the meters to feet and inches. I'm going to change the feet and inches to meters. Again, it doesn't make a difference, but you can do either way and it will still work. So I'm going to look for x inches first, and that's going to equal 11 feet. We'll leave the inches out, we'll add them in at the end. Okay, so we know that 1 foot is equal to 12 inches. So we're doing very similar to what we did in the previous example. We get 132 inches. And don't forget about the other 9 inches that we have to add in. So we'll add in the plus. I'll space that out. So 132 inches plus 9 inches is equal to 141 inches. So the first section, what I've done is I've changed my feet to inches. And you guys know how to do that quickly by just multiplying by 12. And then don't forget to add the leftover inches, the 9 inches, and we get 141 inches. All right. So next, what we're going to do is we're going to look for x meters, and that's going to be equal to 141 inches. So the first thing we want to do is change from inches again, like we did in the previous example, to centimeters. All right. And then we'll need another conversion factor to change the centimeters to meters. So in the first, remember, we can do this as many times as we need to. So remember, the inches are eliminated. Leaves us with centimeters, because the conversion factor is 1 inch is equal to 2.54 centimeters. And then we got to switch the centimeters into meters. So we divide the centimeters, and then 1 meter is equal to 100 centimeters. So we're going to multiply the 141 inches by 2.54 and then divide by 100. So we get 141 multiplied by 2.54. We get 358 decimal 14, and then we're going to divide that by 100, and we get a value equal to 3.5814 meters, which is approximately equal to 3.6 meters. So the question says, the driver knows that the semi-trailer's 3.5 meters high. The support beams of the bridge are 11 feet. So we are able to fit under, not by much, but we are able to fit under the bridge. So since the bridge is just under 3.6 meters in height, and the semi-trailer is 3.5 5 meters in height, the vehicle will fit under the bridge. And obviously, if the bridge was a smaller, then it wouldn't. So it's not by much, but there is enough for the truck driver with the semi-trailer to fit under the bridge. Okay, so there's the 3.5. We needed at least 3.5. We got 3.58. So it's actually a difference of 8 centimeters, which is not much, but it's enough. Check your understanding. I didn't put the answer here. I do apologize. The answer is yes. All right, and you guys can calculate that one on your own. All right. This one's a width, so you guys can work this one out on your own. The answer is yes. I don't have a value right now, but it will fit indeed. Okay. So the homework that goes with section 1.3 is on pages 22 to 23. It's numbers 4, 5, 6, 8, 12, 13, 15, 16, and 18. And you can work on that before moving on to the next section. So thanks again. We're gonna. That's it for section 1.3 relating SI and imperial units. Next, we're going to look at surface areas of right pyramids and right cones. We're going to shift gears a little bit from the measurements. There's also some questions that you can work on. It's basically a midpoint, but we'll talk about those in class. It's a checkpoint 1, but we'll talk about those a little later on. Thank you very much.